Today we're going to learn about, in 5.3, we're going to learn about slope-intercept form. And what that means is in this equation. We have y equals mx plus b. What each of these letters means is something very important. Of course, that the y and the x mean a point. You got the point x, y. But the m and the b always mean something that we've been working with. The m is what we represent as a slope of a line. We've been finding slopes through tables. We've been finding slopes through 2 points. We've been finding slopes from a graph. Whatever that slope is going in front of x, okay? And we did that in 5.2 with that direct variation. When we do something like this, y equals kx, this k is actually the slope. It's the same as saying y is equal to m times x. It's whatever the slope of the line happens to be. The b represents something that we've never noticed before. It is the y-intercept. Now that we know what the slope of a line is and what a y-intercept is, we are going to be able to graph an equation, graph a line, so fast, and we'll be doing that tomorrow. But if you think of how we've normally been graphing a line, we've been creating a table of values and it's been taking forever. Like if I had y is equal to 3x plus 2. Well, I would be don't write this down. I'd be starting off with, I'd choose -2, -1, 0, 1, 2. We get 3x plus 2, and we're going to find our y. This is a long way to graph an equation. We get 3 times -2 is -6, plus 2, which is -4. 3 times -1 is -3, plus 2 is -1. 3 times 0 is 0, plus 2 is 2. 3 times 1 is 3, plus 2 is 5. And then we get 6 plus 2 and 8. And I want you to notice something. Now that we know this equation, that y equals mx plus b, I need you to notice that this is our m. That's our slope of our line, okay? And remember, a slope of a line means you have a rise over your run. So this is saying that I'm going to go up 3 and then over 1 on a graph. And this, according to y equals mx plus b, this would correlate with the b term. So this should be where we cross the y-axis. A y-intercept is where the line will cross the y-axis. I'm just going to make a rough sketch. And I'm not going to be able to go up that far. I'm going to pull a graph in. Okay, if we were to graph these points, I have the point -2, -4, so I'm going to plot it. We go to the left 2, down 4, 1, 2, 3, 4. -1, -1, 0, 2, 1, 5. Oh, you're right. 1, 5, and 2, 8. Now if I were to connect all these points, it is definitely a linear equation. Now knowing this, knowing our new knowledge of y equals mx plus b, the slope of this line should be 3 over 1. So that means go to a point. I should be able to go up 3 over 1 and get to the next point. So I went up 3, 1, 2, 3 over 1, I'm there. 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 So that slope is constant. Now where did I cross the y-axis at? I crossed the y-axis right there. That's called our y-intercept. It's where I intercepted it. And that is 2. Okay? Looking at the equation y equals 3x plus 2, I think we just did that, didn't we?
Yeah, we did.
What is the slope of that line? What is in front of x?
3.
3. We represent it 3 over 1. we write it y equals just 3x, but when we talk about slope, we want to be able to find other points on the line. So you really say 3 over 1. That means you're going to go up 3, and then you'll go over 1 if you were on the graph. And if I asked you what the y-intercept is, where is this y equals 3x plus 2? Where is it crossing the y-axis at? I heard one person say it. I want to hear someone else. 2. It's crossing the y-intercept at 2. That's what's being added here. So this represents our slope, and this represents our y-intercept. I'm going to call it y-int. You're going to see that I'm going to abbreviate that all the time. Looking at the next one, okay, looking at this next one, we have y equals negative 4x minus 2. I want to look at what's in front of my x, and I want to look at what's to the right. So what is the slope of this line, class? Negative 4. And I represent it as negative 4 over 1. And how I say that, or how I would use that to help graph, is I'd say I'd go down 4, and then I go over 1. What is my y-intercept on this graph? Negative 2. Because I have this negative here, my y-intercept is negative 2. Notice here, if we have plus 2, we have that positive 2 for the y-intercept. If we have negative 2, the y-intercept is at negative 2. Y equals 2/3 x plus 5. What is the slope of this line?
2/3.
That would mean that I would go up 2 over 3. That's how we say that with slope. We'd go up 2 over 3. If I was looking for other points. And what is the y-intercept of this line?
5.
My y-intercept is 5. Again, whatever's in front of x is our slope. And this represents where the y-intercept. Now that we're familiar with this y equals mx plus b form, we're going to be asked to apply it in a different level. Not only be able to identify what the slope and y-intercept is, now we're going to be asked to make an equation. This is an equation. That is it. Y is equal to something times x plus something. It's what you've been doing in chapter 4 when you were making equations from a table. It's the same strategy, but now it's way easier. So if I had, for this example, a slope of 3 and a y-intercept of negative 5, well, I want to write it like this. Y is equal to whatever my slope is times x plus my y-intercept. I'm going to call it y-int. So here, my slope is 3. I'd say y is equal to 3 times x, that's my slope, plus my y-intercept of negative 5. Do you think I keep it like that? Plus a negative 5? Do you think that's how the book would want us to do it? We want a minus 5. So we turn this into, that is in simplest form. That would be the answer. If it says to make an equation, you're just being able to identify what is my slope, what is my y-intercept, and just plug them in with what you know. Okay. It really takes no time. The only difficulty is I'm sure that some of us might stop here. And I would count half off because we want to write it in simplest form. And when you plus a negative, it's not in simplest form. You want to rewrite that as 3x minus 5. Okay, this next example, we have a slope of negative 2/3 and a y-int of 5. So again, I want it to look like this. Y equals mx plus b. M is my slope. B is my y-int. So I just plug this in there, and this, in here. As easy as that, just plug it in. So I say y is equal to negative 2/3 x plus my y-intercept is 5. Oh, you guys are Another application of the first part of y equals mx plus b slope is to create an equation from the graph. It's the same technique. You want to find the slope, that's our m. And you want to find the y-intercept, that's our b. Except now we have a graph to find it, and then we just plug in to the y equals mx plus b form. Alright, here's an example of a graph, and we want to create an equation from this graph. The first thing you're going to do is identify slope. So I'm just going to go ahead and pick my y-intercept. Okay, I start with my y-intercept here, and then I want to identify what is my slope. Again, slope is what we went up, rise over run. So it looks like I went up 2 and over 2. So my slope is 2 over 2. Well, what's 2 over 2, class?
1.
So then I know my slope, I know my y-intercept. My y-intercept is right here at 1. So my y-int is 1. Now I can write the equation. Y is equal to whatever my slope is, 1x, plus my y-intercept, which is 1. Do you think I leave it like that, class?
No.
What does that simplify down into?
Plus 1.
Yep, y is equal to just x plus 1. So those are the 3 ways that you're expected to apply the slope-intercept today. You're expected to identify what's your slope, what's your y-intercept. You're expected to write an equation of a line given the slope and y-intercept. And then this last application, a little bit more advanced, when you're expected to create a line from a graph, and you find your slope first. That's what we did here. You find your y-intercept where it crosses the y-axis. That's what we did there. And then you just add them together to finally get your slope intercept form.